Hi, so let us talk about GATE lectures in digital logic design. So what we'll do is we'll try to understand Boolean function representations, that is nothing but SOP and POS, or that is sum of product forms and product of sum forms, and as well as what is Minterms Maxterms. And there are a lot of questions that are being asked in this particular section. So we'll start with lecture. So as you can see, we have Boolean function representations. So there are two possibilities. Either it can be represented in a standard form, or it can be represented in canonical form. Alright, so let us say my function is of a b c. Okay, any Boolean function or any any logic function is of variables of a b c. So if all the terms are having all the variable a b c, then it is called as canonical form, and if it is in minimized form, that is called as a standard form, right? And in all the standard form or canonical form, there can be two possibilities. Either it can be in the form of sum of products, or it can be in form of products of sum. So if I give you an example, let us say sum of products. So basically let us say AB plus A bar BC plus AC bar or A bar C plus some C. So this is an expression which is sum of products. You can see these are products of AB, these are products of A bar BC, and summation of all of them. That's the reason it is called as sum of products. What could be the example of product of sum? So product of sum, I can take an example like let's say A plus B into, let us say, A bar plus B plus C into A bar plus C into, let's say, C. So this you can see, this is a product of sums of the term. So you can see A plus B is a sum, A bar plus B plus C is a term, and then products of all of them. Okay, so this is how sum of products and products of sum. Similar to that, canonical form can also have two terms. One will be sum of products and another will be products of sum. Okay, now the difference that you will see in canonical form is all the term. Here you can see C is missing, right? Here you can see A and B are missing, right? So the thing is, it is in a standard form, or it is in, let's say, minimized form, something like that. Just for an example, I have taken it here. But in canonical form, each of the term will be having all the variables. Okay, so let us say I'll give an example for sum of products. So it will be of the form of like this. Let us say it can be A B C plus A bar B C plus A bar B C bar, like that. You can have sum of products. So products are there and then summation of all of them. What will be the example of products of sum? So I can have same terms as it is, like this: A plus B plus C into A bar plus B plus C into A bar plus B plus C bar. Okay, so this is the example of products of sum in canonical form. Now our aim is to understand what is my mean term and max term. Okay, so let us talk about mean term and max term so that you can have a proper understanding. So we'll start with mean terms and max terms. Let us take first one, mean term. So what happens is, in mean term, the variable will be treated as logic 1 and variable bar will be treated as logic 0. Understood? So basically A is considered as 1 and A bar will be 0. If it is without bar or without like a complement, this will be 1. That's the understanding that you should have. So let me give you an expression. Let's say we have three variable expression like A, B, C, and we have some output Y. So it can have 8 possibilities. You can see that we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay, now the thing is, the Y is considered as first term it can be considered as M0, M1, M2, M3, M4, M5, M6, M7. So this is just understand that it is a small m. Now if you want, you can write it something like this. M0 is nothing but, see, A is 0 here, so it will be considered as A bar. B is 0, so it is B bar. C is 0, so it is C bar. So can I write it down? A bar, B bar, C bar. So similar to that, if I see an expression, this will be M1 will be what? A bar, B bar, C. So similar to that, each one of them you can write it down very quickly. Understood? So what will be that? A bar, B, C bar. It will be A bar, B, C. Then it will be A, B bar, C bar. Then it will be A, B bar, C. Then it will be A, B, C bar. And it will be A, B, C. So you can see A, B, C, all the three are 1, 1, 1. Then it is M7. That is mean term 7. Now a little bit of properties are there for mean term. What I will do is I will just list out here that sum of all mean terms is actually 1. Sum of all mean term is equal to 1. It means if you add M0, M1, M2, M3, M4, M5, M6, M7, you will definitely get logic 1. What does it mean? It means summation of my M0, M1 up to M7 is going to be equal to 1. It doesn't mean that I have to take always 3 variables. If it is 2 variable, you will be having M0 up to M3 only, right? If you are having 4 variables, so it will be having more terms. So it all depends on like how many number of terms will be there for n variable. So total number of terms will be 2 to the power n. Okay, and this is nothing but my sum of products expression. Okay, so basically these are the products and we are going to sum of them, find the sum of them, and this is how you will be finding 1. Now as you can see, a very simple understanding now we can write it down from this is my mean term is what? Mean term can be written as each term in the canonical SOP form. Okay, each term in the canonical sum of products form is a mean term. Okay, so I will define here itself max term also, so that you can have a proper like difference and definition of both. So max term is basically, this is also each term in canonical POS form. Okay, like product of SOP form. So each term in the canonical products of sum form is a max term. Okay, so just like this mean term, we will try to identify the expressions for max term as well. So let us do that. Or before that, what we will do is we will try to write down the mean term expressions. Okay, so mean term expression we will write down very quickly. So let me give you an example. Let us say we have mean term okay. So let us say we have A, B, C, and we have two expressions. One is let's say y1, one is let's say y2. There is a possibility that A, B, C can take the values of all these 0, 0, 0 like that. I will write it quickly. 0, 1, 1 1 0 0 1 0 1 1 1 0 1 1 1. Now I am going to give you an expressions for y1 as 1 0 1 1 0 1 0 1. y2 expressions are 1 1 then 0 0 then what is that 1 0 1 0. Now your aim is to write down my what is my y1 and what is my y2. Understood? So this is how you will be able to find out the expression. So can you see that it can be considered as decimal values. Let's say this is 0, 1, 2, 3, 4, 5, 6, 7. So wherever you see 1 in the expression, that term can be written as min term, right? So I can write down my y1 as summation of min terms of wherever 1 is there, you try to see them, right? So it is 0, then it is 2, 3, 5, 7. Okay, so I can write it down as summation of min terms of 2, 0, 2, 0, 2, then we have like 3, then 5, and then 7. If you want, you can write down the expressions as well. So if you want, you can write down expression how 0 can be written as a bar, b bar, c bar, plus 2 can be written as a bar, b, c bar. You can see here like 2 is a bar, b, c bar. From here I am writing very quickly. So a bar, b, c plus a, b bar, c plus a, b, c. So this is the complete expression for your min term. Can you try out by yourself? Let us see y2. So y2, very quickly I can write it down as summation of min terms of 0, 1, 4 and 6. That's all. If you want to write down the expression, 0 will be a bar, b bar, c bar, plus 1 will be a bar, b bar, c, plus 4 will be a, b bar, c bar, plus 6 will be a, b, c bar. So this is the complete expressions for my min term. So this is how min term representation is done. Okay. Similar to that, we will try to understand the max term concept. Okay. So let us start with max term. In max term, what happens is we consider variable as 0 and variable bar as 1. This is the only difference. Just it is opposite of min term. Okay. So in max term, it is opposite of max term. It is a is 0, a bar is 1. In min term, it was a was 1 and a bar was 0. So can you see? Let us say we have three variables a, b, c, and we have, let us say, expressions like y1, y2. Then what can happen? What can happen? Or I'll just give you an expression of a, b and y, so that you can have an understanding of, you know, like what is min term or how it is represented. So we have 0, 0, 0, 1, 1, 0, 1, 1. Now y can be written as m0, m1, m2, m3. Okay. So can you write down m0 is what? Wherever it is 0, this is considered as 1, right? I mean a. So I can write it down as a plus b. This can be written as a plus b bar. So since b is 1, it is b bar. So similar to that, I can write it down as a bar plus b, and it will be a bar plus b bar. Okay. So you can see a bar plus b bar, it means both are 1, 1. So that's the reason it is m3. Understood? Now let me give you an expression and you can represent this in terms of max terms. Okay. So let us say we have the variable values as 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So total 7 values, total 8 values are there. Now the expressions for y1 is given as 1, 0. Same way I'll just take it, the previous one I had taken 1, 1, 0, 1, 0, 1. y2 is 1, 1, 0, 0, then it is 1, 0, 1, 0. Now if I write down my max term, let us say max term expression. So what will happen? What will be my y1? So y1, what you have to do is you have to find out product term of each of the term in y column. Wherever it is 0, those products will be taken. Okay. So what is the first step that we can do? What is the value you can write down in decimals? Let's say 0, 1, 2, 3, 4, 5, 6, 7. So you can see I can write it down as product of, so this is the symbol for product of max term of, wherever it is 0, those terms you have to take. So this is 1, and then this is 4, and this is 6. So 1 4 6. So I can write down 1 4 6. If you want to write down the expression for them, so what will be 1? 1 is nothing but this one. So this is A B C bar. So I can write down A plus B plus C bar. So wherever it is 0, that is considered as A, and wherever it is 1, that is considered as A bar. Okay. So similar to that, it has become C bar because it is 1. Then fourth term I will take M4. So M4 is this one. So this is going to be how much? A bar plus B plus C. So A bar plus B plus C. Hope you have a good understanding now. How I am writing M4? So capital M4 is nothing but max term of A, B, C, and it is 0, 1. Sorry, it is 1, 0, 0. Okay. Then 6 is A, B, C bar. So it is nothing but what is that? 6. You can see here we have A as 1, B as 1, and C as 0. So it will be A bar, B bar, and C. So it will be A plus B, sorry, A bar plus B bar plus C. So this is my complete max term expression for the Y1 output. Okay. Similar to that, can you quickly do that Y2? So my Y2 will be product of wherever my zeros are there, that you can list out. So this is 2 3 5 7. Okay. 2 3 5 7. Quickly, if you write down the expression, it will be 2. So 2 is quickly what? A plus B bar plus C. Then 3 is A plus B bar plus C bar into 5 is A bar plus B plus C bar. Okay. How 5 is written? Let us say this is my sorry, it is not, yes, it is 5. So it is A is A1, so that is A bar, then it is B, then it is C bar, because 1 is C bar, right? And then 7 will be all the 3 complement form, A bar plus B bar plus C bar. So this is how you have a complete understanding of max term. Now one more thing that is there in the max term is, you have to understand that product of all max term is equal to 0. Okay. So that is nothing but, if I find out product of max term of, let's say 0 1 2 3 from this one, okay, so all these 4, it will be 0. Okay. So this is how. Or if you find out here, like 1 2 3 4 5 6 7, so this will be also 0. Okay. So this 2 variable I am taking up, where my function is of function AB. Now let us see some of the properties for max term and min term in broader way. Okay. So because this is very important topic, so what I am going to do is properties of min term and max term. Okay. So as you can see, number 1, the mean term and max term of same index are mutually exclusive to each other. Okay. So mean term and max term of same index are mutually exclusive to each other. What does it mean? Let us say if I have mean term as mi, then it will be actually equal to max term of ith index bar. Okay, so this is how I am going to tell. Or it can be, let's say mi, then it will be equal to mean term of mi bar. Okay, so this is how it is there. Now we have using using n Boolean variable, we can have maximum mean term is possible mean term is number of possible mean term is number of possible terms is equal to 2 to the power n. Similar to that, number of possible max terms is going to be 2 to the power n. Okay, and at the same time, number of mean term plus max term plus number of max term must be equal to 2 to the power n. Okay, so it means either all of them are mean term or all of them are max term, or the combination of these two must be 2 to the power n. That's all. So let me give you an example. Let us say if I have a function of 3 Boolean variables a, b, c, okay, and we are telling you that my mi is equal to capital Mi, okay, or my mean term bar is going to be equal to my max term. So let us say I take an example. Let's say M6. So M6 bar will be equal to M6. Let us prove that quickly. So can you tell me what is my M6? So M6 of 3 variable is nothing but A, B, C bar, right? So that is 1, 1, 0. This is my mean term expression. So I can write it down. It is nothing but A, B, C bar, okay? Or it is of the form of 1, 1, 0. Now if I take complement of this M6, what will happen? A, B, C bar, right? Then can I write it down from De Morgan's theorem? What was that? A bar plus B bar plus C bar, that is C. And you already know that in max term A bar is considered as 1. So I can see that it is going to be equal to 1, 1, 0. That is nothing but M6. Understood? So this is also nothing but 1, 1, 0 in max term form. So you have proved that mean term 6 index is max term 6 index bar, or mean term 6 index bar is max term 6 index. Okay, so that's all. Now next property is the product of two arbitrary mean term is always 0 for different indexes. So product of two arbitrary mean terms is always 0. What does it mean? Of different index, that is for sure. Okay, so you have to take care of like of different index, like it should not be same index and you are multiplying them and it is going to be 0, not possible. So for example, what I mean to tell you is, let us say my mi into mj is going to be 0 only when I is not equal to j. Okay, and if two multiplication like mi into mi, that will be always mi, that you already know, like a into a is always a, right? So this is how we had already seen in laws of Boolean algebra, right? So for example, let me just tell you m1 into m3. So can we prove that it is going to be 0? Definitely. So let us say we have two variables function a, b, and I want to write down summation of I want to find out m1 and m3. So m1 will be what? Can I write down a bar b, that is my 0, 1 is a1 m1, and m3 is both are a and b are non-complemented form. So now you can see, if we multiply, we are having a product of a bar. So a bar is going to give us 0, so that is anyway going to be 0. Understood? Now another another property for mean term is sum of any two arbitrary max term. Okay, we'll take up max term. So sum of two arbitrary max term is always 0, always 1 for different index. Okay, understood? So this is what I wanted to tell you guys. Now what does it mean? Let us say if I tell you that my sum of m1 plus m4, it must be 1. So can you tell me if it is a function of ab in max term form, what is the relation m1? So m1 can be like, let's say a, b, and this is my y, so 0 0 0 1 1 0 1 1. So which one will be m1? So m1 is 0 0, so that is nothing but my a plus b, so that is my m1, right? Wherever it is 0, that is considered as a, and then m4 will be a bar plus b bar. Understood? And summation of them we have to find out. So summation of them is nothing but what will happen? A plus a bar is anyway 1, plus anything if it is there, that doesn't matter. So you are going to get this is actually bar that you just consider. M4 is nothing but 1 1, so it is going to be a bar plus b bar, and m1 is what is that? Okay, m1. So m1 was what? M1 was this, that is a is 0 and b is 1. So b is 1, it means a plus b bar. Okay, now if you add them up, then what you are going to get? A plus a bar, definitely one of them is there, so it will be 1. So this is why sum of any two arbitrary max term is always 1. Okay, now I have told you not told you about sum of all the product forms and sum of all product of all the mean terms. I think that that is also done, so just quickly make a note. So next property is summation of all the mean term from your 0th values to 2 to the power n minus 1th value is going to be 1 in mean terms, right? Then product of all the max term from your 0th to 2 to the power n minus 1 value is going to be 0. Okay, so if you are taking all the terms as max term in the Boolean expression, it will be 0. So there was a very simple gate question. So question was, I'll just tell you very quickly. For 6 term variable, like let us say, before that I'll just give you here, I told you for n variable function, number of mean term plus number of max term is equal to 2 to the power n. Okay, so what it told is, like for 6 variable function, it is told that mean terms were 28. Mean terms are 28. How many number of max terms are there in the expression? Okay, so what will happen? You know already that mean terms plus max term must be how many? 2 to the power n, that is going to be 2 to the power 6, that is 64. So it means my 28 plus max terms will be 64. So the number of max term will be how much remaining? 64 minus 28, that is going to be how much it is? 36. So this was a gate question, very simple question. Like we had 6 variable function, the number of mean terms were given as 28. So how many number of max terms will be there? So 36. So what we'll do is, we'll take up couple of questions in max term, min terms, and then we'll try to solve. So those all questions are from GATE previous years, from EC, EE, and instrumentation and computer science. So alright guys, thank you.